All right, back for another session. Got a couple more interviews to get through, a couple more applications to send out. So, gotta keep practicing. Okay. Okay. Let's see what we get. All right, let's go ahead and get started. A narcissistic number, given an integer n, return whether it is equal to the sum of its own digits raised to the power of the number of digits. Okay, so this narcissistic number is going to be, I think, converting it to a string, and then just doing these like offsets. Because you need to know the power first and foremost. So what I want to do is do string num equals n. I'm going to concatenate that plus n. Cool. And now what we're going to do is keep track of the sum. And we're going to do for int I equals 0, I is less than num dot length. I'm going to increment this by 1. Cool. So we're going to do sum plus equals math.pow. We're going to up num dot char at I. We're going to offset that by 0 to get an actual number to the power of nums dot length. Easy. Equal to the sum of its own digits raised to the power of return. We're going to return n is equal to sum. Easy. Not going to compile. That's okay. Huh? Wait, what? Why is that an illegal start of an oh. Right. It helps to put it inside of the appropriate brackets. That'll do it for you. Not nums, it's just num. There we go. 21%. Okay. How can we approach narcissistic number faster than actually doing the multiplication? I think probably what's slowing us down is the fact that we're converting it to a string and working with strings. Wow, that's a great hint. I love it. Let's add a hint. Let's do this. Calculations. There you go. Let's go ahead and add a hint. It's always cool seeing my name at the bottom of some of these things. Like, my name, I think, should be at the bottom of that question soon enough. Well, maybe not now. Okay. Intervals intersecting at point. You are given two-dimensional list of integers intervals. Ooh, the sun is, like, peeking in and out of clouds. So, each element contains start and end, represented as an inclusive interval. Return the number of intervals that are intersecting at point. So first things first, what I want to do is I want to sort them. I want to sort them by their start time. Just like that. And then what we do is we say, we want to keep running through it until start is greater than point. What this will allow us to do is not have to check all of them. Though, granted, this is n log n. It might be faster to just iterate through everything in n, but I guess it might average out at some point. And just count. That's pretty much all we're going to do. So we're going to do arrays.sort. And we're going to sort intervals. I think we need lambda expression for this, if I'm not mistaken. But for now, let's just do maybe lambda. Cool. Then we're going to iterate through all the intervals. I is less than intervals.length. I++. Cool. So what we're going to do is say if, let's keep a count up here. I'm going to say basically if intervals at I at 0 is, intervals at I at 0 is less than or equal to point, and intervals I1 is less than or equal to point. Cool. So what this is going to say is if it starts at or before the point and it ends at or after the point, it's going to be greater than or equal. There you go. Then we can do count plus plus. Otherwise, the only thing we can check here is to say else if. I'm gonna fix this indentation here. Else if what? If it starts past the point. I 0 greater than point. Because we sorted them, we know that because it's sorted, we know nothing past this will intersect. So we can break from the loop. And then here, we can just return count. Easy. This is an error on which line here? Solution 11. Yeah, so it is this. We're gonna do A, B at 0, minus A at 0. Sweet, okay. Let's get rid of this comment. I think that should take care of our issue. Wrong answer. Okay, that's fine. Am I doing it? Let's do this real quick. .println. We're gonna print out these things right here. Gonna see what we're doing because it's hard to remember if you sorted these right. 1. Sweet. Okay, let's see what we get. Oh man. Okay. Let's run it. Compile error. Yeah, that'll do it. Not having semicolons will do it for you. Wrong answer. Okay. 1013, we did sort it wrong. A minus B. Okay, perfect. And let's submit. Watch it TLE. Oh, okay, yeah, it's because I got the println. I was gonna say, man, there's no way my solution is that slow. So let's see what this gives us, right? A 20%. What if we do this and we just remove this if condition? Will that make it faster is the question. I guess it does. I guess the fact that it's O of n scales it differently. Okay, let's run this a few times. Maybe... Okay, so maybe this is the faster solution here. Okay, 84. Let's put back this one. And run this one a few times. See, maybe it is that much slower. Wow, so the time complexity of this is just kind of nuts. Okay, let's go ahead and get rid of that. So we're kind of quite literally just have this super simple solution here where we just brute force check every interval because it's faster than sorting the intervals. Oh, it froze. You know what? I say this is the good enough solution, yeah. Because it hit 84 percentile. So these are both ways to do it, but I think this is one of those times when it's really important to really consider your time complexities. for whatever it is that you're working on, because sorting it might seem like the straightforward answer, but in this case, not sorting it and just brute forcing the oh, good grief, okay. Just brute forcing it and just running it in O of n is that much faster. Uni-value tree, unibind tree, return whether all values in the tree are the same. Easy. I'm gonna step out for a second and then I'll be back to solve this uni-value tree. Alright, let's see what we got. So, for a uni-value tree, what I want to do is do a post-order traversal. The reason I want to do post-order is because I need to know the state of the entire tree below it before actually working with, oh hey! Alright, so I need to know the entire state of the tree below it before actually moving forward and doing anything with the tree. So we're going to do a post-order. And for every one, I want to compare it to its left and compare left and right subtrees, left and right children. And then pass up the Boolean comparison. So what we're going to do is say solve if root equals null, so, return true, because we don't really care for nulls. Then we're going to say Boolean left equals solve root dot left, Boolean right equals solve dot right. And then what we're going to do is to say so how can we do this comparison, right? If it's null, we want to return root. However, if it's not, what do we want to do? That's a great question. Let's compare the and right nodes. So we're gonna say int left equals 0, right equals 0, if root dot left does not equal null, then left equals root dot left dot val. And we're going to do the same check for the right side in the right child. Let's say this is val because we're already checking the booleans up there. Let's change this to right val. Root dot right dot val. Okay. Okay. Oh my goodness. Someone, you beat me to it. Okay, so what we're gonna say now is return left and right, and left val equals right val. And I think this should be it. Compile error. Okay, Melissa figured I'd get the low-hanging fruit first. I feel like all of these problems are low-hanging fruit. Wrong answer, okay. Because these can be 0 if one of them is null. How can we actually tackle that? How can we... Oh my goodness, why is this hard? This should not be difficult. What if we do this? Just set it to the root value, otherwise, if it's null, we'll just hold on to this root value. Yeah, okay, easy. Okay, what's our last one here? Elephant tree. Given a binary tree root, return the same except every node's value is replaced by its original value plus the sum of all of the left and right subtrees. Oh, easy. This is once again where we utilize a post-order traversal. Cool. So we're going to, I guess, just quite literally copy most of this code here. Let's copy this, paste that in there. Post order, sum left, sum right, return up left plus right plus curve, and that's easy. So what we're going to do is, once again, if this is null, we're going to return a 0 because it has an inherent value of 0. We're going to solve left, solve right, sum up the values. So we don't need left val, right val. We don't need any of this. So what we're going to say here is, we're going to do root.val is going to be equal to left plus right plus root.val. And since this node is going to be the sum of all of its predecessors plus itself, what we can then do is, as the sum of the entire subtree, pass up root.val. And I believe that should just take care of it. Let's fix this indentation. And indent it all up by 1. Boom. Alright, run it. Compile error, that's okay. Int. There we go. Still does not compile, huh? Oh wait, it wants a root back. I just noticed what it wants back. What I think we're gonna do with this then, right, is to just say, let's put this into a helper method. Public tree sum up. There we go. So here, instead of solve, we're gonna call sum up. We're gonna do sum up on root and return root. So this should fix our issues by allowing us a different return type, and we solved it. Yeah, I figured that out once I actually looked at it. Well, that was good. Welcome. It's been a while. Good to see you. It's good coffee. Okay. I'm not quite sure what to do. I mean, I've been live for half an hour and solved this. Cool. It's good when it's good, and it's bad when it's bad. Yeah. Okay. Transferred from community college. I really wish that they'd fix this one bug where if you control backspace, I wish you'd put a space back in. Cool. I mean, I always feel like solving such problems again when I join job orientation preparations again. Hey man, you're more than welcome to! Exclamation. Wait, which way? That. I always forget which way to point here. But yeah, up there, exclamation point room. You can hop in. They're very, very easy ones. Yeah, I'm like, I think close to wrapping up these streams kind of for good, to be honest. I have landed, I got a Microsoft offer, so if I can get them to a point that I'm happy with, I might just usually hang around in gaming streams. This is, I mean, it's close to gaming, right? I mean, the only thing on the line here is my career, so it's a pretty fun game to play. But yeah, if I can get Microsoft to a place I'm happy with, I might just kind of stick with their offer and I guess be done leak coding. It's weird because I've been at this since what? Oh man, when did I start? Hold on. I started streaming. Okay, so that's May. That's when I was preparing for my internships. Yeah, I started streaming back in September. And so September, October, November, December, and Jan. That's like 5 months, dude. I did take a bit of a break in December for Christmas, but I'm back. So after 5 months, 5 months of grinding, it's heat map greenest. Yeah, man, I'm telling you, it took a lot of work. I'm still waiting on, I think Google is the one that I finished my final interview for, but I'm still waiting on a response. But so far, Microsoft is my 4th job offer, and so far I'm happiest with theirs, I think, out of all of them. But thankfully they're, willing to negotiate. So I'm trying to negotiate them up to something I'm a bit more happy with in terms of RSU and join on bonus. But I'm really excited, really happy to have landed it. That's better work-life. Yep, definitely. The other 2 companies, one was based where I am. The other one was based across the country. They're, not bad companies by any means, but their base salary was just quite low. So I received the third offer. I took that one, but the company recently got acquired by another company, and from what I've read everywhere, their work-life balance and just overall office atmosphere has gone downhill pretty fast. And Microsoft has probably one of the best work-life balances that I've seen when it comes to companies. I think Microsoft and Google are the two that are sort of up there in terms of good work-life balance. Maybe a little bit lower on the paying side, but they have good work-life balance. I think Amazon is the one where you go if you want to just like make stupid amounts of money, but also have no life outside of work. And then there's Facebook, which I think is very close to the best of both worlds, but they didn't even respond to my application, so. Garbage. Okay. Yeah. I know we have a couple people who are joining Amazon from our kind of university, and the biggest concern is just getting piped after like 8 months and getting thrown off. That's why I'm just gonna hopefully chill with Microsoft. I mean, if I can get my RSU up to like a really nice amount, it'd be nice. The sign-on bonuses, man, it's like, I think for like Amazon, like Facebook and all these companies, like their sign-on bonus sometimes ends up being more than like the average salary of a US household in a year for like just signing on. It's crazy. Oh, absolutely backend. I can't stand front end. If you look at any of my projects that I've done by myself, the backend is like clean, functional, everything works, bug tested, and the front end is just garbage. Oh man. Like here, if I can bring up an example here, give me 1 second here. Looking at Microsoft negotiations. I wonder if I can get this here without showing specifically the URL. Ooh, binary search did not like being put back into light mode. How do I turn off this? Oh wait, let's put it back in dark mode and turn off the extension. There we go. So yeah, this is, let me resize this, make sure it fits. Cool. So this is my personal portfolio, right? If you look at it, here it doesn't look bad. It looks a lot worse on mobile, but yeah, you can see this is the extent of how I was able to lay out my projects. This one, full stack project. This one, full stack project. This one's not really full stack. This is Java with PDF parsing, and I need to update these projects. But all of these projects, full stack, look great. My portfolio is garbage. If you look down here, you can't really even see it. Let me move this up a little bit. There you go. If you look at this, I'm pretty sure the contact me part of it isn't even like a line. There's no padding here. This is not, none of this is aligned. But I mean, it gets the job done, is all that matters. I'm really proud of this graphic that I definitely did not just copy off Google. But yeah, this is the extent of my portfolio. I'm not sure if it helped me get a job, if any of the recruiters ever looked at it, but let me see if I can pull it up on mobile. Open it on mobile device. So it looked like that there. This is what it looks like on mobile. What framework it worked on? Mostly for backend, I'll work either in Java. I was utilizing Spring Boot at my internship, or it's mostly I'm a Node.js kind of guy. I use Node.js for all my backend. I tried to use React for the front end, but I haven't worked with it in so long I kind of forgot the framework. And mostly Express.js for what's it called? Portfolios visit safe. But yeah, like if you look at it, the padding for some reason here is just gone. All my projects are now left aligned for some reason. At least this fits, right? Yeah, mostly working, I use the MERN stack. Where is it? MERN stack, yeah. So Mongo, Express, React, and Node. But most of the time I'll swap out Mongo. Yeah, React it's super nice. See, you hate it because you don't like front end. Probably. Unless you just prefer Angular. Because yeah, most of the time though, it'll either be MERN or CERN. I'll swap out, really, Java backend now. So are you still, what, student, employed, senior engineer who wants to give me a referral to whatever company they're at? Spring, I hated every second of working with Spring. I cannot tell you how confusing the whole like change of mindset to these things being services rather than like running programs and figuring out the friggin' the beans and like passing things in and learning all the annotations. Oh, congrats, congrats. Yeah, that's awesome. I'm glad you were able to land something. Yeah, no, this framework is the one that I learned in my boot camp. Junior dev for 1 year. Hey, I'm hoping to be like you. Hoping to be like you working for, oh gosh, for, this is it, isn't it? I graduate in March. I'm done with all my education. And now I get to go work till I die. It's not a very reassuring prospect, if you ask me. Hopefully I can set up my 401k and make good calls on investments so I can just retire early and go get to enjoy my life, not in my 60s. Sad if you put it this way. It is, huh? See, but the thing is, one thing I heard kind of from one of my interviewers was like either a department manager, like a team manager at Microsoft, and I asked him, what about Microsoft that made you decide to stay at the company rather than, the job market's hot, there's a lot of companies out there. What made you decide to stay? And the way he put it was very nice. He says, Microsoft understands that people don't only want to make money, but also want to have time to spend that money. And from what I understand, they are discouraged to work outside of working hours. Like, you're discouraged to send emails past working hours and expect a response the same day, which is a lot nicer than I think Apple it was. Like, I was speaking to someone who was working at Apple, and they were working minimum 50, 60-hour weeks plus being on call on weekends. And it's like, man, how much does Apple pay? Hold on. Kind of curious. Great website. Let's look at the average Apple salaries here for SDEs. So entry level, 126k base. Man, for 126k working 60-hour weeks, that's not very nice. Yeah, no, this isn't. I wouldn't. I much prefer work-life balance, man. I'm not even from CS background, but just grinded LeetCode. You see, this is what it's kind of nice about the tech industry because it's open to anybody who can pretty much grind LeetCode. But I guess it also says a lot about the companies and what they look for, like not necessarily even learning as I'm working. So wait, so what experience did you have besides grinding LeetCode when it came to like working, a foundation of like data structures, algorithms, like any sort of like frameworks, design patterns, anything like that? Or did you literally just grind LeetCode and get there? Because if you manage to grind your way through LeetCode and math and uni, okay. That's wild, dude. The fact that you just grind LeetCode and get it. Granted, that is pretty much all I was asked. I guess the other thing that was very important to know when it came to these interviews was time and space complexity. 6 months prepared for grinding. Okay. Hey, well, congrats. You did something that I know I wouldn't be able to do. Because, I mean, at this point in time, many companies don't specifically even look for a CS degree. It's just like a nice thing to have. The reason I went in to get a CS degree was because I knew that I personally would not have sort of the dedication and willpower to sit myself down for the 1 to 2 years it would take me to go through this material myself. I could have saved a lot of money, don't get me wrong, would have been, a lot cheaper to do it that way, but I know that I wouldn't get, I know that I wouldn't learn. I'm finishing up my bachelor's this upcoming March. So I feel like for me, this education wasn't more of like, hey, I need the degree to get a job. It's, hey, I want to have this, I want the knowledge that they offer. Yes, absolutely, I could do it myself, purely like off of like YouTube courses, Udemy courses, Brilliant, whatever other websites. But I tried a Python course on Udemy, made it through like 2 weeks, maybe not even 2 weeks, maybe like a week worth, and I just never touched it again. So being forced with deadlines like you are in uni, as much as I complain about it and as much as I say I hate it, like it's what got me through. There's also the full stack bootcamp that I took in August 2020. spent 6 months in the boot camp. It was pretty much like another college, probably like another college quarter stacked on top of it. I'd say you had 3-4 hours worth of like lecture or like modules to do a week. You had a weekly project to do, which would take you about, again, maybe 4 or 5 hours depending on the difficulty, and then you had 4 hours of like meeting up lecture with your kind of cohort to do. And then on top of that, for bootcamps here, my company had us train in bootcamp prior to allocating projects. Never again. Honestly, I think it depends on your experience. I had a really great experience with this one. The instructor was very, considerate. The material was laid out in a way that was very, very nice. One of my favorite things about it, if I go back to my portfolio here, through pretty much all of my projects on here, like this one, this one, this one, this one, and this one, all came from that bootcamp. So it allowed us to work in a team, and for 6 weeks for front and back end, we had to design a banking feature. Yeah, see, this one was spread out over 6 months, and the intention was that you came in having absolutely zero CS background. You didn't know what an IDE was, you didn't know how to write pretty much anything. Started you off with HTML, CSS, then it went into JavaScript, and then it went into a little bit of object-oriented JavaScript, then moved on to Node.js, working with Node.js as a whole, working with Express, and then working with databasing like SQL and MongoDB, and then moved on to React in the final few weeks. So it was definitely a very good experience on my end. I think if I try to even open this app, it won't even go to the deployed app because my domain has expired. I just didn't want to pay for the domain. It was like $50. So I didn't want to pay GS. Really? Okay. Because personally, GS has very quickly become one of my favorite languages. Like, I work primarily in Java and JavaScript. I think it depends entirely on what I am doing. Just hate dynamic typing. I can definitely see what you mean. I've had a lot of instances where you go into JS and this function right here, type of, becomes the most useful thing because you're expecting one thing and then you run type of. Yeah, see, there is that, but the flexibility of JavaScript to be both a front and back end language. No, runtime issues definitely suck, especially when you end up with especially when it just crashes and it takes you ages to figure out why. It's a lot easier to find bugs and crash reasons in statically typed languages. Node in the tree, add its value to the set. Set cannot hold. You have experience in functional programming. Not a uni-value tree. Yeah, so my experience with functional comes entirely from using Erlang. Erlang was, to be completely fair with you, not too difficult. Kind of inclined, feels like math, honestly. It is, a lot of it is, fast space, then computational power. At least if I can pull up some of my Erlang stuff here. Exam.erlang. Examine. Okay. I can probably copy some of this Erlang code. It's not very... Maybe it is kind of clean Erlang code. So, let me go back to mine. Let's see, let's put this in some comments. This is some of the Erlang code we had to write for our class. The biggest thing that Erlang taught me was to utilize tail recursion more often. Because, for example, if you really think about it, looking at our questions, this is utilizing tail. No, this isn't tail. This is just bottom up. The other ones are bottom up, but a lot of things can be done using tail recursion, and it becomes quite fast. However, though, switching my brain to this sort of programming paradigm was good to see you, man. Good to see you. Yeah, switching my brain into Erlang was a nightmare because our exam consisted of it was like a multiple choice portion, and then given prompts and things to solve in both Erlang and C. Writing the C portion, there's a language I hate. It's C, man. C is such a nightmare to work with. Probably just because I'm not familiar. And then afterwards, right away, you go into your Erlang portion, and you're still kind of in the C mindset, so kind of shutting that off, taking a little bit of a break, and going into Erlang and functional was a bit of a nightmare. Looking at this now, I mean, I'm not sure if I could ever write this again. Yeah, no, I got my call this morning. They woke me up at like 8:30, 8:40 in the morning. Called me, told me they had good news, I got an offer. I was like, I've been getting a lot of spam calls recently, so for some reason this time it didn't identify the number as Microsoft, so I almost just didn't pick up. I think what's funny is my first sort of technical I got scheduled, I'm pretty sure I was streaming, and I got a call from Microsoft, and I had to like pause and then go do that and take care of that. Sadly, I'll lose your streams too. Yeah, it's all good. It's, I might be back every once in a while. Not really sure what to do, but have fun in your streams. Yep, thanks, man. I appreciate it. I think I am gonna kill it now. I gotta go figure out my C assignment because, oh goodness. Memory allocation and figuring out. Okay, pointers themselves aren't bad, but when you have a pointer to a pointer sort of structured like this, which is like, I think this can be technically counted as sort of like a 2D array. Get that guitar and do a music stream? I might one day, man. I haven't touched it in months. But yeah, no, it's gonna be weird stopping streaming. I think I'm gonna keep going for still a little bit until I finally sort of settle. M-block. Yeah. I hate it with a passion, man. I can't figure out for the life of me how to like dynamically allocate for different string sizes, because what this is saying, right? It's pointing. It's a pointer to a pointer to a character. The pointer to a character is technically this right here is technically, it points to if I'm not mistaken, points to car, which is the first car in null terminated string. But what I think you can do here is increment this pointer, right, to get to different characters in the string. By incrementing this pointer, you can get to different strings. Overall, I've gotten so many segmentation faults, man. My core has been dumped so many times. I shut it off yesterday at like 11 p.m. and I was like, I'm done. I'm over it. I'm not doing this anymore. But yeah, probably gonna be here for maybe another week or two until I'm still waiting on Google to get back to me. So I do want to be here to. Yeah, no, I hope to not have to work with C, because thankfully, if I do stay at Microsoft, all of their stuff is entirely in C#. And if you've never used C#, it is pretty much Java with like a fresh coat of paint. So it's Java without all the Java issues, from what I understand. So yeah, that's gonna be it for me, guys. Actually, you know what? Before I go, I'm gonna go over the time and space complexity of these solutions, just to, I guess, keep that muscle working out. Okay, so here, just O of n time, I guess, O of n space maybe for the string, but it is entirely just O of n time. Let's say O of 1 space, because we're just every time making one string. This one is going to be done in O of n time. Initially, my solution utilized a sort to potentially cut off having to traverse the other half of the list, because if we sort them by start time, we know that anything after the first one that does not start before or at the point everything after that also won't start there. But turns out that sorting things is just more, I guess, time expensive than just iterating through everything. So I guess that makes sense, because to sort, you do still have to iterate through the entire array, and then doing it again to, like, you're basically not cutting anything out. Instead, you're doing an n log n traversal of the whole array, as well as then doing a, at worst case, O of n traversal with this loop right here. Space-wise, it's still O of 1 because we're not utilizing any extra space, just our constants. Univalue tree is done in O of n space, or O of n time with O of 1 space. The reason it's an O of 1 space is because we're not doing anything besides saving variables, and the reason it's an O of n time is because we're traversing the tree only once. Yeah, these were a nice refresher. Cool. Moving on to the next one. These two problems are pretty much identical. Elephant tree just uses bottom-up recursion. This is where, man, post-order traversals have become my new favorite, because I used to do kind of top-to-bottom recursion, and that required me to, like, keep random variables up here, and I had no idea how to do this, like, bottom-up passing of variables. But utilizing a post-order traversal guarantees that at every state, every node you're at, you already know whatever it is you're trying to find out about all of the nodes below it and its left and right subtree, which we can see by doing sum up to the left and sum up to the right here. What this does is just, again, if it's 0, returns 0. Otherwise, it updates this current root node to the value of its left plus right subtree plus itself. And because the next one up requires the total sum of the left and right subtree, we want to pass up that sum by returning root.val. And time O of 1, O of 1 time, jeez. Time is O of n, and space would be O of 1. Alright, that's going to be it for me. Thanks everyone for stopping by. I'll keep everyone updated on any other potential offers. Take care.